Hello. Today, we have a great problem to solve. Our goal is to find the limit as x goes to infinity of x to the power 1 over x. We all know that the limit as x goes to infinity of 1 over x is 0. We also know that the limit as x goes to infinity of x is infinity. Consequently, the limit as x goes to infinity of x to the power 1 over x is initially equal to infinity to the power 0. So, the initial evaluation of this limit will give infinity to the power 0. Which is an indeterminate form. This means that we should use the L'Hospital rule to address this issue. As a matter of fact, the main function, x to the power 1 over x, is an exponential function. So we need to use a logarithmic transformation to simplify this problem. So, we set y equals x to the power 1 over x. Then, by taking the logarithm on both sides of the equation, we get logarithm of y equals 1 over x times logarithm of x. Here we are using the inverse properties of logarithmic and exponential functions. Now, we will be studying the limit of logarithm of y as x goes to infinity. Please do not forget to like the video and subscribe to our channel. Thanks. The new problem we should study is the limit as x goes to infinity of logarithm of y, which is equal to the limit as x goes to infinity of 1 over x times logarithm of x. However, we know that the limit of logarithm of x as x goes to infinity is infinity. This is still an indeterminate form of the type 0 times infinity. In fact, in order to solve this type of indeterminate form, we need to use the L'Hospital rule. However, this rule primarily applies to the case of 0 over 0, or infinity over infinity. So, the first thing we have to do is transform the product 1 over x times logarithm of x into a fraction. We naturally rewrite the expression as the fraction logarithm of x over x. The new expression of the limit is limit as x goes to infinity of logarithm of x over x. So using the L'Hospital rule, we know that the limit as x goes to infinity of logarithm of x over x is the same as the limit as x goes to infinity of the derivative of logarithm of x over the derivative of x, which is equal to the limit as x goes to infinity of 1 over x over 1. This is because the derivative of the logarithm of x is 1 over x, and the derivative of x is 1. So it is clear that this comes down to the limit as x goes to infinity of 1 over x, which equals 1 over infinity. This is obviously equal to 0. In sum, the limit as x goes to infinity of logarithm of y is 0. Recall that the original expression, x to the power of 1 over x is equal to exponential of y. This is because logarithm of y was defined early as logarithm of the quantity, x to the power of 1 over x. Here we are using the inverse properties of e of x and logarithm of x. So, the limit as x goes to infinity of x to the power of 1 over x is equal to the limit as x goes to infinity of e of logarithm of y, which is equal to the exponential of the limit as x goes to infinity of logarithm of y, which is e of 0. And this is equal to 1. Finally, the limit of our expression x to the power of 1 over x when x goes to infinity is 1. Thanks for watching the video. Please like and subscribe to our channel. Thanks.